In the last video, we introduced this concept of this marginal utility per dollar. And we are talking about this marginal utility per dollar. Basically, it shows the cost of additional satisfaction. And I want to dive into that just a little bit more. So as we dive into that, we've got two different goods. We've got a cup of coffee and a cup of tea. And in my example that I'm going to use right here, both cups are worth $1 each. So let's say that you go to drink one cup of coffee, or you're going to go in and you're going to drink that second cup of coffee. Now me, I like coffee. I've got a cup sitting right next to me. So I go to drink that second cup of coffee, and that second cup of coffee is going to provide 21 additional units of satisfaction. So my marginal utility is 21 units, or 21 utils. Now, I'm going to go ahead and divide that by the cost of that cup. And that cost of that cup is $1. So, naturally, my marginal utility per dollar is going to be 21. We have 21 divided by 1 equals 21. Now, if this cup of coffee was, say, $2, let's say that you're going to go down to Starbucks and spend $2 on a cup of coffee, or even more than that, it would be 21 divided by, in that case, 2. Meaning that this would be about 10.5. But in this case, we're going to keep it simple and keep it $1. So it shows that by drinking that second cup of coffee, you get 21 units per dollar. You drink that third cup of coffee, you get 17. The fourth one, you get 14. The fifth one, you get 10 units per dollar. Now let's look at tea. Now I do like a good glass of tea, especially a nice glass of very sweet of sweet tea and iced sweet tea. But let's say that you can get tea for $1 as well. Both of them are caffeinated drinks, so they're going to be substitutes, something that we're going to learn a little bit more about later on in this chapter. So I can go and drink that second cup of coffee, get 14 additional units, and by doing the math of 14 divided by 1, we get a marginal utility of 14 units per dollar, 14 utils per dollar. So let's stop and think about this. If I were to go have a second cup of either coffee or tea, which one do you think I might choose? Well, what do you think I'm going to choose? I'm going to choose the one with the highest utility. So that additional satisfaction per dollar would be 21 units. So I'm going to go with the second cup of coffee over the second cup of tea. Now, I look down here. Down here, I would rather go with the third cup of coffee before ever consuming this second cup of tea anyways. Because again, I get a higher amount of satisfaction than I would over here. But as you remember, what happens to marginal utility as you consume more? As you consume more, marginal utility, as we see here, begins to fall. So the additional satisfaction per dollar, what do you expect it to do as you consume more of one good? It's going to fall. So we get down here to that fourth cup of coffee, and we could be consuming that fourth cup of coffee, and it's going to yield 14 units of satisfaction per dollar. Up here, I could do the same thing off that second cup of tea. So let's stop and think about how all this is going to work. I'm wanting a lot of caffeinated drinks today. I drink my first, second, third cup of coffee. And somewhere in there, I'm probably going to have my first cup of tea somewhere. I'm not quite sure where, but I have a cup of tea in there. And then I get down to this fourth cup of coffee. I could either have my fourth cup of coffee or my second cup of tea. Which one do I choose? Well, both of them are equal. They provide the same amount of utility. So I'm indifferent on that point. I can either go with that second cup of coffee or the fourth cup of tea. And provided my budget allows for me to get that far, I'm going to be somewhere in between the two. Now, let's say that I go ahead and drink my fourth cup of coffee, and then instead of drinking that fifth cup of coffee, because now tea yields a higher amount, I switch to 2 cups of tea, and then 3 cups of tea, and then I'm indifferent on the fourth cup of coffee and the fifth cup of coffee and the fourth cup of tea. Long story short here, ladies and gentlemen, that as you drink more of one good or consume more of one good, the marginal utility falls, making that marginal utility per dollar amount fall. And you're always going to go, or you're going to consume, given your budget, where that additional cost or that additional satisfaction per dollar is going to be equal across the two goods. Otherwise, you're going to choose one over the other. Okay, so now that we've covered this marginal utility per dollar, or that cost of additional satisfaction, and we know that the cost of those additional satisfaction must equal each other if we're dealing with two different goods at consumer equilibrium. Otherwise, we're going to choose one over the other. So we already know that. We know that that's going to take place. But what is all this building up to? Well, it's building up to this concept that we are going to start diving into a lot heavier, called demand. So the demand of each good is influenced by the consumer prices and income. The demand for a good is going to be influenced by the income and the prices. Now, that should start sounding kind of eerily familiar because that's dealing with this lovely budget constraint down here on this graph. Remember that a budget constraint is basically created because of the price of two goods and the income or the budget associated with those goods. So the demand is going to be of each good is going to be influenced by the consumer income and prices. So, for example, the demand for hamburgers is going to be a function of the price of hamburgers, the price of tacos, and the income. So the price of other goods and the price of the own good and the income. Then we're going to throw in this nice little lovely Latin word called ceteris paribus. Ceteris paribus meaning holding all else constant. When we're looking at evaluating changes in demand, especially how changes in demand or changes in price affect demand, or changes in income affect demand, we are going to hold all else constant. We are going to basically take the market forces and say nothing else can apply to this. We're looking at just prices or just income. So whenever we use this ceteris paribus, it's Latin meaning holding all else constant. That is an economist's way of saying we're not going to allow the market to fluctuate except for looking at just prices. So in this case, we're going to be looking at only price or income and how only price or income affects demand. So let's start off by looking at price changes. So if we're looking at the demand for burgers or the demand for tacos or demand for both, what happens if the price of burgers change, but we keep tacos and income the same? So we're going to use kind of our previous examples where income is $5. Tacos it costs 50 cents a piece. So if you remember, we can buy a grand total of 10 tacos. So we can buy 10 tacos, and at point A, or on this middle budget constraint, the burgers cost $1.25. So this was the original number that we started dealing with when you're dealing with all of these examples. So we draw our budget constraint. At the maximum, you could buy 10 tacos. At the maximum, you could buy 5 hamburgers if you only bought 5 hamburgers. Then we have our lovely little indifference curves in here. And then we find that point of tangency, that consumer equilibrium, giving that budget constraint and that indifference curve, and we are at point A. And we see that we are in consumer equilibrium on this budget constraint at 2 hamburgers and 5 tacos. So we're going to consume 2 hamburgers and 5 tacos. But what happens if we change this price? So we're going to go ahead and change the price, and we are going to decrease the price of hamburgers. And we decrease the price of hamburgers to $1. So now we could buy, we have this new budget constraint out here. We're at the maximum. We could buy 5 hamburgers or 10 tacos if we bought just one or the other. So we draw our new budget constraint. We draw all of our indifference curves out, and we see that there's a point of tangency at point B. So we now can consume 4 burgers or 5 tacos. So let's stop and think about what happened here. The price of burgers fell. So just think about this in your own life. If the price of burgers fall, what are you going to probably do? You're probably going to consume less hamburger or consume more hamburgers because they're cheaper. And we see that exact same thing happen. But you can only consume so much before you start to get full, right? So in this particular case, you actually consume less tacos. But what if the price actually decreased, or price increased for hamburgers to $5 a piece? Now what's going to happen? Well, we have a brand new budget constraint. We see that the price of hamburgers rose, that therefore indicating that the budget constraint rotated in this manner, rotated back clockwise. And we see that the amount of burgers fell. Makes sense, price rose. And actually the amount of tacos rose. Well, makes sense. We consume less hamburgers, we might consume more tacos. So why is all this happening? Well, stay tuned because that's what's going to be coming up in the very next video.